All right, let's start this morning with solutions to the last lesson that we did. And we're going to have the first one being example 1, where we'll see that y is equal to 3x squared minus 2x minus 5. And then y plus 7 is equal to 5x. Let me just put my phone on silent. Hold on. All right, let's start back. All right, so this is the first question that we have to solve, and we're going to go given that y plus 7 is equal to 5x, and we'll call this equation number 1. And we're also given y is equal to 3x squared minus 2x minus 5. I'll call this equation number 2. And then I'm going to rewrite equation number 1 because it makes it easier for me to rewrite it. Although I can probably do something like substituting this entire thing here. All right, let's go from there. So substitute. No, it will make trouble later on. Let me not do that. I was going to substitute this here into this and then simplify and solve. But then when I have to solve for the other variable later, I would have some issues when it comes to finding them because I don't want to have to substitute into this entire thing over here. So let me just take this off. And now we're going to say from 1. We'll have y is equal to 5x minus 7. I'll label this as equation number 3 so I can reference it later. And then I can say substitute 3 into 1. No, 1 made 3. So 3 into 2. Right? And then from there, we're going to have this going in here. We're going to take this piece here and replace the y over here. So we're going to have something like 5x minus 7 equal to 3x squared minus 2x minus 5. And then we're going to simplify and solve this. So we're going to have here 3x squared minus 2x minus 5x minus 5 plus 7 equals 0. Simplifying, we get 3x squared minus 7x plus 2 equals 0. And then we can factorize this, I believe. Yes, factorizing this is possible. Let me just check it out. So this is 2, that's 3 and 2, that's positive 6. And we'll have 1 by 6 and 2 by 3. And then we're going to take 1 by 6 to get the 7. So we're going to say minus 1 times minus 6 is going to give me that 7, and I'm going to get a positive 6 when I multiply them. So yeah, so let's go 3x squared minus 6x minus x plus 2 equals 0. And then we'll have here that 3x into x minus 2, and then minus 1 into x minus 2, so that we can make the factors the same. And now that the factors are the same, we can just say x minus 2 into 3x minus 1 equals 0. And now I have two factors, and I can say that either x minus 2 is equal to 0 from the factor theorem, or 3x minus 1 is equal to 0, and that would mean that x is equal to 2 or x is equal to 1 over 3. Now I can say using x equal to 2 in equation number 3, which is the one that I just had right here, I can get that, what was that again? 5x minus 7. So y is equal to 5 into 2 minus 7, which is just simply 10 minus 7, which is 3. And then I can say using x equal to 1/3 in equation 3, we can see that y is equal to 5 into 1 over 3 minus 7, and that will be 15. Well, that's 5 and 1/3. So let me just change this up a little bit. 5 3s are 15, and then 16 over 3. And then 7, I multiply the top and the bottom by 3. So the 7 is thought of as over 1. I multiply the top here by 3, bottom here by 3. That's essentially multiplying by 1. So that will give me minus 21 over 3. And then that will be 21 minus 50, right? 16 minus 21. So that gives me 415 over 3, right? Negative. Right? So from there we can get that hence we have that x, no, I can say the 2 points are, we can have x is equal to 2, and then we have 3, and then the next point will be 1/3, and you know what, let me just change this. This will be -1 and 2/3. We're going to have here -1 and 2 over 3. I think you can solve this on your calculator and get your answer for your x. Let me just verify that. Let me get the calculator out and it's in mode, and I am seeing equation 2. So 2, and then three value equation, quadratic equation. So we put in 2 here, and let's check the a, the b, and the c. The a, the b, and the c. Let's see. Let me just scroll up here a little bit. Yeah, the a, the b, and the c here. So we have the a as the 3. Let me just point that out. We have a as 3, b as -7, and c as 2. So we just open that calculator back up. So a as 3, -7, and then 2, and then you get x1 as 2, which is what we have over here. So that's verified. And then we have 3, 3, 3 recurrent, which is the same as 1/3, right? So 1/3 over here. So we can just do that, and we can reset this calculator, or we can just go back into mode and go back to normal. And this is one thing I usually like to do when I have like long polynomials like these to solve. I like to do this. Let me just show you it really quickly. So I will say 5x, let's see, not there, 5x, oh, 5x, oh, that just takes long, right? 5x, and then, oh, I'm supposed to use alpha, right? Let me just make sure it's that. Oh yeah, lovely. Okay, so 5, I'm not accustomed to this model, so I'm just showing you it's possible. So 5x minus 7, right? And we'll get 18y, because if I recall the value on x, I will see that x stores 5. If I take 2 and I store it on x, right? And I go back up to the original equation I just had there and I press equal, I will get 3. So right away, the answer that I'm supposed to get, which is the 3, is right here. So this is why I like to do this, because now if I want to solve the next one, I don't even have to type this over again. All I have to do is just say type 1 over 3, store it on x, go back up here, which the original equation I want to solve, press the equal sign, and I get -5 and 1/3. And whew, I made a mistake here, right? 5 and 1/3, right? So, oh, I did crazy things here. Let me fix it, right? Crazy things here. So this here, I thought of this as 5 and 1/3, which is a mistake. I'm supposed to take the 5 multiplied by the 1, which will give me 5 over 3. So let me just change this up here. Fix this, fix this, fix this, fix this. Right? So I'm going to have here 5 over 3. So I'm going to have 5 into 1 over 3 minus 7, and this is supposed to be 5 over 3, and then when I multiply this by 3, and this is over 1, so when I multiply this by 3 over 3, I'm supposed to get 21 over 3, and then this here is going to be minus 16 over 3, and this here is 5 3s are 15, so we're going to have 5 and 1/3, -5 and 1/3. This answer here needs to change to -5 and 1/3, right? And that there is the answer that I'm supposed to have. So this is a good thing that I know how to double check this on the calculator. I'll double check my answers later on as well to show you this methods again. All right, so let's continue with the solutions. The next question that we have to do, and somebody started chainsaws in the background. The next question that we have to do, example 2, is that y plus 5x is equal to 6x squared plus 2, and we're supposed to solve simultaneously with y plus 7 equal to 5x. So I'm just going to solve that now. So given, I'm going to put this one on top. Yeah, is this the same question? No, it's a different question. Okay, it's a different question. All right. So given this, um, we have y plus 7 equal to 5x. I think this here is an error. Y plus 7 equal to 5x. Just give me a second. Let me double check this because I don't think this is correct. Right? I don't think this is correct. Let me just double check this a moment. Hold on. I think I copied down the wrong equation. So I need to confirm that I have the wrong equation and writing the correct one. Um, hold on. Ah, these errors happen sometimes. In quadratic, and we're looking at simultaneous equations. And just go that. And last question, right? It's supposed to be y plus 4x minus equal to 3, right? It's supposed to be y plus 4x. So this is the PDF of the previous lesson. So it's y plus 4x is equal to 3, right? I thought I wrote that down properly, right? So this is y plus 4x is equal to 3, right? So let me change this out from here. Right, so then I get y plus 4x is equal to 3. Right, that's good. Let's continue now. So we have here that y plus 5x equal to 6x squared plus 2. We'll call this equation number 2. And then what we're going to do is we're going to take equation number 1 and rearrange it so we can make the substitution here. Again, we don't want to substitute this into here because later on it'll be troublesome to solve a quadratic just to find your x values. It can be done, but it's just troublesome for me. So from equation 1, we can simply say that y is equal to 3 minus 4x. And we'll call this equation number 3 so that we can solve, well, we can refer to it easier later on. So let's substitute equation 3 into equation number 2 here. And we're going to get that, we're going to replace this here, this y, with that, and we're going to get that 3 minus 4x plus 5x is going to be equal to 6x squared plus 2. And from there, what do we see? Let's rearrange. So we got 6x squared. This is just going to be 1x, and when you carry it over to the next side, it's minus. So we have minus x. We're going to have plus 2 and then minus 3, and that's equal to 0. I'm just going to erase this and put minus 1. Right? So simplify and get there. And then we can solve the quadratic here by factorization. So this is minus 6. We have 1 by 6 to get 6, 2 by 3 to get 6. And now we need to figure out which product form will be added together to give me minus 1. So I'm seeing this one here, and I'm thinking minus 3 plus 2 is going to give me minus 6. And when I add them together, I'm going to get the minus 1. So I'm going to say 6x squared minus 3x plus 2x minus 1 equals 0. And let me add a new page. This one here is going to be 6x squared minus x minus 1 equals, oopsie, that's not what I'm doing, I'm factorizing. So 3x into 2x, so minus 1. And then I can see the exact same thing, so I'm going to say plus 1 here, and 2x minus 1 equals 0. So this means I have 2x minus 1 as one factor, and then 3x plus 1 as the other factor equal to 0. And then from there, I can say that either 2x minus 1 is equal to 0 from the factor theorem, or 3x plus 1 equal to 0. Well, and 3x plus 1 is equal to 0. All of this is from the factor theorem. So it's either 1 or both needs to be 0 for that to be 0. And we have x is equal to 1 over 2. X is equal to negative 1 over 3. And I can say using x equal to half in equation number, what is this? Equation number 3 up here is 3 minus 4x. So equation number 3, we have y is equal to 3 minus 4x, and we have y is equal to 3 minus 4 into a half. This here is going to be equal to negative 2, and that means that 3 minus 2 is going to be equal to 1. We're going to say using x equal to negative a third in equation number 3, we have that y is equal to 3 minus 4 into negative a third, which is going to be a positive 4 over 3. 4 over 3 is 1 and 1/3 positive, so that means we're going to have 3 plus that, so it's 4 and 1/3 as the answer there, and hence your points of intersection are going to be a half and 1, and the other one is going to be negative 1/3 and 4 and a third. Right? Those are your solutions. Let's go back on the calculator again and try and see if we can get the answers. And I'm going to try and make sure and show you all the capabilities of your calculator a little bit more often now. Right? First things first, we have to solve the quadratic. So let's go back up to the quadratic. Where's the quadratic? There's the quadratic. Right? So we're just making sure that we have equation number 2, and we're looking at quadratic, which is number 2 again, and we're saying 6 as a minus 1, oopsie, delete that, 6 as a, right, 6 as a, minus 1 as b, and then minus 1 again as c. We're going to have 0.5, which we know is a half, and we're going to have negative 1/3, right? So we know it's a half, and we know it's negative 1/3. So now all I have to do is just simply take this equation, put it on my calculator, and then substitute these values for x, right? And that will allow me to get the answers quickly. So let's look at this equation here again. So go to mode, go back to normal, and we can see that 3 minus 4 and alpha x to label it, to write the label, and then we're going to say that is what we're going to have. We're going to have a half first, so 1 over 2, and we're going to store that on x. We're going to go back up to the equation, press equal, and we get 1, which is what we did get, 1. And then we're going to do the same thing again. We're going to take negative a third here. So we have negative 1 over 3, we're storing that on x, get negative a third, we're going back up to the equation, we press equal, and we get 4 and 1/3, 4 and 1/3, so it works out correctly. Right, so you can do that just to do your quick calculations and verify that everything is correct with your calculator. Let's go on to the next equation. And I'm not going to be going into great detail so much anymore. Right? Not going to be going into great detail so much anymore. I am going to write the equation. Let me just write this out. Y equal to 2x plus 1. And then we have x minus 1 squared plus y minus 2 squared equal to 10. So what I'm going to do is I'm going to solve, get the quadratic, and then I'm going to take the quadratic, put it in on the calculator, and then solve for my values afterwards. Actually, you know what? Let me not do that. Let me just continue going through the solutions. Right? So given that y is equal to 2x plus 1, I will be talking less, however. I don't think I need to explain so much anymore. Squared plus y minus 2 squared equal to 10. We call this equation number 2. We're going to say substitute 1 into 2. So I'm going to take this and replace this y here. So I'm going to be getting x minus 1 squared plus open bracket y, which is 2x plus 1 minus 2 close bracket squared equal to 10. And this is going to be annoying. Let's see, x minus 1 squared plus 2x minus 1 squared equal to 10. And then I can use my property a plus b squared is the same as saying a squared plus 2ab plus b squared. And I can expand my quadratic easily. So I can have x squared minus 2x plus 1 as that one expanded. And then I can have plus 4x squared minus 4x and then plus 1 equal to 10 when I expand it. So I'll have here 5x squared minus 6x plus 2 equal to 10. I'm going to just minus 10 right away here equals 0. So I'll have 5x squared minus 6x minus 8 equal to 0. Let me see if the calculator can work out this quadratic. Right? If it gives me too much of a fraction, I wouldn't bother. Alright, so this here is 2, 2, and my quadratic tells me 5 minus 6 and 8, so 5 minus 6, 8. And I get 0.6 and 0.6. Wow, 0.6 and 0.6. That means that, okay, well, let me double check this and make sure. So we're going with 5 by 8 is 40, so negative 40. We're looking for anything to give me that 6 in the middle when I add them. So I am thinking I'm using 10 and 4. And I'm saying if I have a negative 10 with a positive 4, I'll be able to get a negative 40. And if I add those two together, I'm going to get negative 6. So I'm going to say here, this here is 5x squared minus, minus what, like 10x plus 4x minus 8 equal to 0. And we're going to have here 5x into x minus 2 close bracket plus 4 into x minus 2 close bracket equals 0. And I'm going to have x plus x minus 2, and I'm going to have here 5x plus 4. I did something wrong on the calculator then. Most likely I did something wrong on the calculator. Alright, let me check over my values. So I have 5 as my A. I have negative 6 as that B. Oh, I didn't put a negative 8 as my C. Right, so I get 2 and 0.8. See? Negative 2 and 0.8. Yeah, I'm getting that. So either 5x plus 4 is equal to 0, or we have x minus 2 is equal to 0. X is equal to negative 4 and 5, and x is equal to 2. Right, and then from there we're going to say using x equal to minus 4 over 5 in equation number, I think we have equation number 1, so that is y equal to 2x plus 1, and we're going to say y is equal to 2 into negative 4 over 5 close bracket plus 1, that is negative 8 over 5, so we have here negative 8 over 5, and then I'm going to multiply the top and the bottom here by 5 because this is just simply 1 over 1. So that is going to be 5 over 5, and that is negative 8 plus 5, negative 3 over 5. And then I'm going to say using x equal to 2 in equation number 1, and I'm going to see that y is equal to 2 into 2 plus 1, that's just 5, equal to 5. Right, there we go. And that means that I'm finished with that solution. Hence, the solution is that we have negative 4 over 5 and we have negative 3 over 5. And the other one is going to be 2 and 5. That's the solution for that one. Let's move on to the next question that we had to do. Example 4. We have that y is equal to negative x plus 4. And then we have here that x plus 3 squared plus open bracket y minus 1 close bracket squared is equal to 25. I'm going to solve these simultaneously. So we say given that y is equal to minus x plus 4, that's what I'm going to call 1. And then we have x plus 3 squared plus y minus 1 squared equal 25. This is equation 2. And we can say substitute. Right and bad. Substitute 1 into 2. So we're going to take this here and replace this y. We're going to get here that x plus 3 squared plus open bracket minus x plus 4 minus 1 squared equal to 25. And we're going to expand this just like we did the previous one. So we're going to have x squared plus 6x plus 9. And this here is going to be minus x. So we're going to have plus x squared. This is going to be plus 3. So this is minus 3 minus 6x. And then we're going to have 3 squared, which is 9. And then we're going to minus the 25 equals 0. And then we're going to have x squared, 2x squareds. This here would cancel off with this over here. We'll have the 18 minus 25. 18 minus 25 is 7, negative 7. And that's equal to 0. Okay. From there, what we can say is that 2x squared is equal to 7. And then x squared will be equal to 7 over 2. And then x would be equal to the plus or minus square root of 7 over 2. And that there, on plane geometry, I can do a video on plane geometry. That's possible. Oh, thanks. His first comment on this lesson. I'm gonna get one on plane geometry. I will try and do one on plane geometry then. Okay. Let me just finish off what today's lessons is, and then I'll move on. All right, so then I have here using x equal to positive, negative, well, let's just say positive then. Positive 7 over 2 in equation 1, we're going to get minus x plus 4. So we're going to say y is equal to minus of root 7 over 2, and then plus 4, and then we say y is equal to minus, well, let me just put it as 4 minus root 7 over 2. I'm going to leave this like this for now. Later on we'll learn surds and how to rationalize this and make it look a little prettier, right? Just a little bit prettier. And we're going to have using x as being equal to negative root of 7 over 2 in equation 1, and we're going to get, oh, why did I put a negative? Right here, negative. And then we have y is equal to negative, open bracket, negative root of 7 over 2, and then plus 4, right? So that's this equation here. And we're going to get that y is equal to 4 plus root of 7 over 2. So the solutions are, hence, we can see that the root of 7 over 2 gives me 4 minus root of 7 over 2. And the other solution is that the negative root of 7 over 2 gives me 4 plus the root of 7 over 2. Right? And, right, that's that. You know what? Let me just put this here. Right, so that. And then we have to go to the next one. Did we have another one? No, that's it. Number 4. 4 examples. Let me just double check with the PDF again. Should need some intermission music. I gave 4 examples, did I not? Or 5? Let me check. 4 examples, right? That's the last example there, right? So it's 4 examples that I gave. That's the solution to the 4 examples. And with that, let's come to terms with what we just did. Again, we are here. Let me just write that out. We are doing the section algebra, sequence, and series, right? And we have done algebra section already. We have done the quadratic section already, because that's what we just completed. Right? So we just finished this one here. Now we're going on to inequalities. Oopsie. Let's put this here. Inequalities. That's the next topic that I'm going to do. So this is the next one that we have to do. And just so you can remember where we're going, we still have to do surds, indices, and logarithms. And then finally, after that, we have sequence and series, right? So we're at the third section right now in this first part, and it's only going to be about 2 lessons long. Then we're going to move on to surds, and then we're going to do sequence and series, right? So let's start the lesson that we're supposed to be doing today. And today's lesson is about quadratic inequalities. Let's write this as blue. Quadratic inequalities, right? And the objective straight out of the syllabus is to determine the solution sets of quadratic inequalities using algebraic and graphical methods. All right. And in the previous lessons that we do so far, which you can see is this section on quadratics, you already learn what a quadratic looks like. You already learn how to solve them when they're equal to 0, right? Now we will look at the situation where instead of an equal sign, we will have a relational operator, right? We'll have a relational operator. And those operators that you should know by now is the ones for greater than, equal to, less than equal to. Those are the relational operators we're going to learn to use now. So you will see when we're doing this that when you have a solution, you're going to get not just 1 or 2 values, but a set of values, right? You're going to get a set of values or a whole range of values, right? A whole range of values, and you would have to state your answer in set notation. So if you don't know set notation, go and check out my video on set notation that I think I did already. If not, then I'm going to have to do a set notation video. Just let me know if you need set notation video. Right, so now let's answer a simple question of where you're going to use this, right? Why is it necessary that I need to learn how to solve a quadratic? And I'm just going to write it here: ax squared plus bx plus c greater than equal to 0, or any one of these operators here can go inside of here, right? Why is it we need to do this? In a situation where you have some problem to figure out, and the problem is a quadratic, and you have some condition to fulfill. You know what, that is sounding so vague. All right, let's say for instance, you're running a business, right? You're running a business, and let's say that this quadratic, just put it right here, this quadratic that we have is the quadratic for your business, right? And this symbol here is going to be an inequality. What you're going to do is, let's assume that this here is your cost. And I know this is not really something that might happen, but let's say that this x variable represents your cost, and this quadratic represents the selling price based on your cost, right? Let's say it represents a selling price based on your cost. These A, B, and C are just simply factors that need to be taken into account. They are going to be constant number factors, right? But just assume that the cost is X, and the result of this is going to be your profit. If you represent this as an inequality, what you can do, instead of just simply getting one value, you can get several values. You can get a range of profit. In other words, a range where well, let's say that this is a function, right? you're going to get a range when your function is greater than 0, which is your profit. You can get a range, you can get a value for when your function is equal to 0. You already know how to do this, which is your break even. And then you can have a value where f of x is less than 0, in other words, your loss, right? So you can actually get a range of values that you can still make a profit on, or you can get a range of values that you will be making money, you will be losing money on, or you can have here, which is what you already know how to do, which is find your break-even point. Okay. All right. So before we go into doing this type of work, we need to have some definitions, some foundations. Now, you should have a basic definition and foundations of inequalities, but I'll just try and remind you of some of the important ones. So let's do some definitions. Definitions and properties. Right? Definitions and properties. Let's say, let A and B be members of this set of real numbers, and let's look at some of the implications of using a relational operator with these. Right? Then something like A greater than B would mean that A minus B is going to be greater than 0. What does that mean? It means that the difference is positive. Right? And let me just put something here. I'm going to say that this is a relationship, and I'm going to call this the meaning. Right? And we're going to look at all of them. We're only going to look at, well, yeah, we're going to look at all of them. Right? Then we can look at what? A less than B. And that would mean that A minus B is going to be less than 0. In other words, the difference is negative. Then we have A being greater than equal to B. It would mean that A minus B is greater than equal to 0, meaning that it can be both positive, the difference can be both positive, or it can be 0. Right? Not both, sorry, it can either be positive or 0. And if it is that we have A less than equal to B, then we can have A minus B is going to be less than equal to 0. And that would mean that we have positive, sorry, not positive, negative, or 0. Right? And here's a couple things that you need to remember as well, along with these relationships. And that is that for any real A, B, exactly one of these is true, and that is that A must be either less than B, it must be equal to B, or it must be greater than B. Right? So one of these must be true. I'm trying to make sure that I state that, because just now I made the mistake both positive or 0. Right? I made a mistake there. But notice that for any real A and B, you must have one of these conditions here. Right? And another one, let's say, you know what? I need to add another variable here. Let me just put C here. Right? So I'm going to say if A is greater than B, right? And we know that B is greater than another variable C, then we know that A must also be greater than C. Right? That is just simply something that follows. Right? So if A is greater than B and B is greater than C, then A must be greater than C as well. Okay? And then let's look at some basic operations. Right? So we understand the meaning of what each of these symbols are, and we understand some rules that have to take place, and we understand this here, let's go ahead and look at some basic operations. Basic operations, right? The first one that we can see is that you, let's say for instance you have x is greater than 2. Then if I decide to take x and add 3, then it's going to be greater than 2 plus 3, which is 5. Okay, so the rule is that you can, and I'll just write this, add or subtract the same number from both sides of an inequality without changing its direction. All right, and I'll just write this in a little bit of bold so that you can see it. So I can say add, subtract, right? You can add or subtract anything like that. And then let's move on to the next page. Let's look at another example. Another thing that you can do is that if we have x greater than 2, right? Then if I take 3 and I times it by x, then I can take 2 and times it by x. Sorry, 2 and times it by 3. We just write it in the same form. So 3 times 2. I can have that, and it still holds that 3x is going to be greater than 6, right? So next rule is that you can multiply or divide both sides by a positive number without changing the inequality. Right? Let me just write that in a bolder orange. So multiply or divide by a positive. Right? You can multiply or divide both sides by a positive number and the inequality wouldn't change. Is there a situation that it can change? Yes, there's a situation that can change. Right? For example, if x is greater than 2, then if I take, let's say, negative 1, x and divide it by negative 1, right? It's going to be, it's greater than there, so it's less than negative 2 divided by 1. Why do I say this? Well, you can check this with some pure numbers. Let's say, for instance, you have 2 is greater than 3. And let's say I divide this by negative 1 and I divide this by negative 1. I will get negative 2 and I'll get negative 3. Right? But is it the case that negative 2 is greater than, is it the case, oopsie, I made a mistake here, less than. Right, so 2 is less than 3 and I divide by negative 1 and I'm going to get negative 2, negative 3. And is it still the case that negative 2 is less than negative 3? No, that's not the case. Negative 2 is greater than negative 3. So that's why we can say with certainty that negative x is going to be less than negative 2. Right? So in that term, the rule is if you multiply or divide by a negative number, the inequality sign reverses, right? So I'm just write that a little bit bigger. Multiply or divide by a negative reverses, right? So if you multiply or divide by a negative number, the inequality sign reverses. Let's quickly solve an example. So let's say example 1. Let's say we have x squared minus x minus 12 less than 0. All right, for now, let's just ignore this less than 0. Right? Let's just ignore the less than 0. Let's solve it and factorize it like we would a regular quadratic that we have. So given x squared minus x minus 12 less than 0, we're going to have something like minus 12 as the factor, and we're going to say maybe 1 by 12 can give me 1, 2 by 6, 3 by 4. Hey, yeah, that's the one right there. So I can have negative 4 and a positive 3. When I multiply this, I'll get negative 12. When I add them together, I'll be able to get negative 1. So I will get factorizing. Then we have x squared minus 4x plus 3x minus 12 less than 0. And we're going to say x into x minus 4, and then plus 3 into x minus 4 less than 0. And I'm going to have x plus 3 close bracket into x minus 4 close bracket less than 0. All right. Now, this is the part where we start using our inequalities knowledge, right? This is where we're going to start using inequalities knowledge. Everything so far is something that you know how to do already. And what we're going to do now is we're going to talk about the inequalities knowledge that you need to finish the solution. So now there are two methods to determine the solution set of the inequality, right? There are two methods, and they have called it the algebraic method, and the graphical. Right? So what I'm going to do is I'm going to take this exact same problem and I'm going to just continue from here with the algebraic method. And then once I'm finished with that, I'm going to take this from right here and continue with the graphical method so that you have an idea of how both of them differ and how to use them. Right? So let's start with the algebraic method. I'll write that one in blue. So I'm just going to write here algebraic method. Right? So let's start. For all mn that belongs to the set of real numbers, we have the following facts, right? So this m and n here that you're seeing is nothing more than the factors here. So this is m and this is n. So something multiplied by something less than 0, right? So we have this factors here, m and n less than 0, right? We have the following facts. Let me just write them out here. For if we have m, n greater than 0, then we will know that we have m being greater than 0 or n being greater than 0. Or we'll have that m is less than 0 or n is less than 0. Now just think of this, right? Just think of this as two positive numbers will give me a positive number, right? Two positive numbers will give me a positive number, which is this, and two negative numbers will give me a negative number. So if m is positive and n is positive, multiplying m and n will give me positive. Positive meaning greater than 0. If n is negative, if m is negative and n is negative, multiplying m by n is going to give me a positive, right? And that's really and truly how you think about it. The product gives me something greater than equal to, less than equal to, in the case such that this here is fits a condition, this here fits a condition. That's literally all I'm listing right now. So if that m n is greater than equal to, then we know that m is greater than equal to 0, n is greater than equal to 0, or m is less than equal to 0, n is less than equal to 0, right? So again, I'm just going to repeat, that just means that if this gives me a positive result, then this must be positive, this must be positive, this must be negative, or this must be negative, right? So that's the situation that I will get positive in. Okay, same thing follows for here. If I'm going to get a positive or equal to 0, then this here must be positive or equal to 0, or this here must be positive or equal to 0. Or if I'm going to get negative equal to 0 or negative equal to 0. Okay, let's go on to the next one. So if mn is less than 0, then we have the case where we have m is going to be greater than 0 or n is going to be less than 0. Meaning that if I'm going to get, let me just finish right all this, or m is less than 0, n is greater than 0, right? Let me just write this out again. So if I'm going to get a negative value when I multiply m and n, then it means that either m is going to be positive and n is going to be negative, or it means that m is going to be negative and n is going to be positive. Okay? And let's do the last one. So if m n is less than equal to 0, then we know that m is greater than equal to 0, n is less than equal to 0, or m is less than equal to 0, n is greater than equal to 0. Okay? All right, that's that. So we know now how to decide what to do with this. So if this here and this here multiplied by each other is less than equal to 0, we see, wait, is it less than equal? No, it's just less. So if that is the case, then we see that this here is the condition that suits the one that we're working with. All right, and let me just write that out in the solution format so that you can see it. So either m in this case is x minus 4, I believe. Let me see. Yeah, x minus 4 and then x plus 3. Oh, x plus 3. All right, let's put it plus 3 here. Right, so x plus 3. I'm trying to keep it in sync with what it has there. Right, and x minus 4. Right, so it's either this here is greater than 0, less than 0, or this here is less than 0, or this here is greater than 0, right? That's the cases that we're going to have, and that's this situation here, right? Now, we need to find the critical points. Therefore, it means that x is going to be greater than negative 3. Remember, we can minus from both sides. So we just treat this like an equal sign, and we just find our critical points, and we just remember, we just put this back in. The only time we reverse that sign is if we multiply or divide by a negative number. So we have that, and then we have here that x would be less than negative 4. My neighbor started, sorry, positive 4. My neighbor started washing down with a pressure washer. Okay, sorry about that. And then we have here that x would be greater than, sorry, not greater than, x would be less than negative 3, and x would be greater than 4. Right? So yeah, right. Now, how do we determine whether this solution or this solution is the correct solution? To do that, we simply draw a number line. Okay? We draw a number line, and I'm just going to draw this number line right down here, right? And the first thing you're going to do is you're going to decide whether or not you're looking at less than symbols with equal sign or without equal sign, right? On the number line, symbols with this is just going to be an open circle. Symbols like this is going to be a closed circle. Symbols like this is an open circle. Symbols like this is a closed circle. All right. You know what? I did not do that properly. Let me just undo these. This here is missing a 0. And let me just put this in at the bottom over here. This here is closed because it's equal to. This here is open because it's not equal to. This here is closed because it's equal to. Right? So those are the symbols that you would use on the number line to represent greater than, equal to, and less than, greater than, equal to, less than, equal to, greater than, so on. You understand? Right? So we take the critical points and we line them up in relation to each other. So we know that -3 is going to be over here, and 4 is going to be somewhere here, and then you're going to have a 0 in the middle somewhere over here. Right? That's the minimum amount you need to put on the number line. Okay? Then what we do is we look at the symbols. We see in here that this is greater than -3, less than 4. So we're looking at greater than -3. So right where we have this -3, we put a circle because we're looking at greater than, and then we draw a line going from this side to that side. Right? We do the exact same thing for the other one. So at 4, let me just put this here. Right there. Then we're gonna have this here. We're gonna put a circle again because we have less than. There's no equal sign there, and then we're gonna draw a line going less than. Right? Now what we're looking is for the region of overlap. We notice that this region is overlapping here. Let me just shade that region of overlap here. Right? So that's the region of overlap. Now what I usually like to do is I like to draw under each of the arrows in one direction, and you can see the overlap fairly easily. Right? Let's go with the next one. Just draw that out. So I'm going to have -3, I'm going to have 0, I'm going to have 4. I'm going to put a circle here, and I'm not overlapping. I'm overlapping them now because, well, you should understand where it's going from now. Then here, and in this case we have this direction. Oopsie. Take this off. This direction, and we're seeing that it have no common region. So let's see. Here we have common region. So therefore we have a solution. In this one, we have no common region. So that means that here has no solution. Right? Now we state our solution. So this is our solution here. We're seeing that it's valid for greater than -3, less than +4. So we say, hence, the solution set is the set of x such that -3 is going to be less than x, which is less than 4. Right? That's the solution. Now, let's go on to the graphical method, which I tend to prefer. I don't like this method. It takes too long for me, I find. Right? Because, I mean, after you reach here, you have to figure out what conditions you have. Then you're going to have to list them, work out both conditions, draw two number lines, figure out where they're intersecting, and where they're intersecting is the one with the solution, then state your answer. I like the graphical method. The graphical method, I just simply draw a sketch. We'll see that right now. Right? So let's go to the graphical method. Graphical method. Right? To find the solution using this method, we first sketch the graph and then shade the region of interest. Should just call that a ROI. Anyway, So from the quadratic that we have, let's go back to the quadratic. This is the quadratic that we would have had here. Sorry, here. Right, that's the quadratic. These are the factors. These factors would give me the critical points, the roots. This here would give me the quadratic itself. So from the quadratic that we have, which is what again? Right, x squared minus x minus 1. So from x squared minus x minus 12 being less than 0, we see that a is equal to 1, which implies we have a minimum turning point, right? And you don't even need the intercept, which we already know here is going to be negative 12. We don't need that. We know we need to know the critical points. The critical points are based on your factor theorem when x plus 3 is equal to 0. So we get x equal to minus 3. Or when x minus 4 is equal to 0, that means x is equal to 4. Those are our critical points, right? So the critical points are x equal minus 3 and x equal to positive 4. All I have to do is just simply draw a minimum curve now. Let me just draw a little nicer one. Make sure that you like this form easier, right? This here is my x-axis. This here would be my function axis or my y-axis. And this here would be my negative 3. Let me put it as I'm supposed to. Negative 3, right? And this here is going to be my positive 4. Remember, I am not closing the circle. I'm not shading it in. I'm not closing the circle because this here is, oh my God, and it starts raining. I hope you all can hear me properly right now while it's raining. Right, so this here is negative 3 and this here is positive 4, and we have here, hence, the solution set is, open bracket, x minus 3 less than x less than 4, close the bracket. Why we have this? Because above here is when y is greater than 0. Right here is when we have y is equal to 0. And right here is when we have y is less than 0. Down this way. Right? So let me just put this out to the side. Anything along this line is y equal to 0. Anything above the line is y greater than 0. Anything below the line is y less than 0. This is our solution here that we're interested in. We're interested in the less than 0. Less than 0 is below the curve, so right here. And because that is below the curve, that is the solution. Notice that this here is the solution. Minus 3 greater than, less than. So x lies here. Right? X lies in this region. So it's going to be minus 3 is going to be less than x, and it's also going to be less than 4. Okay, that's how we get this solution over here. Now, we finished just in time. I really hope you understand the last explanation, even though the rain started pouring outside. I'm going to give you an exercise to do. This is the exercise. We'll solve it next time, and hopefully anything that you missed while the rain started pouring, I will be able to fill that in for you. So, exercise, solve x squared minus 4x minus 5 greater than 0, algebraic. And then we're supposed to solve x into x plus 3 bracket less than equal to minus 2 graphically. And then we have number 3, solve minus x squared plus 6x minus 8 greater than equal to 0. And you can use any method, graphical, algebraic. Use your favorite one. All right, that's it for today. I hope you find this lesson useful. It was a long one. I will see you for the next lesson, hopefully when it's not raining and I don't have to shout and you can hear me properly in the background. All right, enjoy the rest of your week if it is that I don't see you, but enjoy.